Hi, we are going to go over some recursive equations for quadratic functions. We did this in class today, and I just wanted to make sure you guys felt like you had enough information to do this well. So first thing is I'm going to remind you what the actual equation is. So this right here is the recursive equation that we use for quadratics. I'll get this right in a second. There we go. F of n equals f of n minus 1 plus the second difference times n, and then plus or minus some number that you have to figure out. So that seemed to be where like a little bit of the challenge was today. So I'm going to do a couple examples that were different than the ones we did in class. And so hopefully by now you've copied this down. By the way, copy it down as many times as it takes until you have it memorized. So let's do an example. It's going to be with rectangles, but I'm not going to draw it on graph paper because it's actually like way too big. So my first example actually weirdly starts on term 3, and you'll see why, I think. So this is term 3, and this rectangle is 1 by 18. 1, 18. Zoom that in a little. And then for term 4, we're 2 by 24. And then for term 5, we're 3 by 30. If I were you, I wouldn't take the time to count all these out either. Okay, so there's my pattern. And the next thing to do is going to be to make a table of values. So let's do an X and Y table. And sorry, I left my notes someplace else, but I think I can do this off my head. Actually, I want to leave a little space here. So let's start with 3, 4, 5. And we'll leave room. Let's go ahead and see if we can figure out 6 also. And of course, you're pausing the video right now and doing this yourself, right? Okay, so you're back. Good. So let's look at this table of values. And you got term 3 was 18, I'm sure. Term 4, 2 times 24, 48. Term 5, 90. And term 6, I could figure it out because we had a pattern here. 1, 2, 3, 4. And then the top was 18 plus 6 is 24, plus 6 is 30. So I'm like, oh, I bet that's 36. And then I did 36 times 4. So I got 144. I'm going to leave these two for a minute. Now, what's the first difference here? 18 to 48. Well, that's 30, right? 8 minus 8 is 0. 4 minus 1 is 3. 48 to 90. I always remember that 45 plus 45 is 90. So then it must be 48 and 42. I need something else that equals 10, right? 40 and 40 is 80. And then 8 and 2 makes 10 more. So it's 42. And then for this one, to get from 100 to 144, I go up 44. To get from 90 to 144, I must have to go 10 more. So that's 54. All right, here we go. Let's see. 42 minus 30, I could do that upside down. 2 minus 0 is 2. 4 minus 3 is 1, so that's plus 12. A 54 minus 42, I can do that upside down. 4 minus 2 is 2. 5 minus 4 is 1, plus 12. Okay, good. So I've got a couple plus 12s here. So it looks like that's going to be my second difference. And so we know this is a quadratic function. Because the first differences are always changing. It says always. No, you can't see it anyway. First differences are always changing. And the second differences are constant, which means never changing. So there we go. I spelled constant wrong. C-O-N, constant. There we go. So with all this information, I wonder if we're ready to write our equation. Let's see. Do we know our second difference? Yeah, it's 12. Do we know how to figure out this other number? Well, yeah, we can figure it out just using like algebra, kind of our math skills. So what we'll do here is we'll say, let's write the equation again. So this is the blank version of the quadratic recursive. We can go ahead and fill in. Our second difference is going to be 12 times n, sort of like a linear equation, 12n plus or minus some other number. So the next step is, how do we find that other number? I'll call it the last number of the equation. Right, this one right here. Well, we're going to use some of the information that we already have. So let's say that we know f of 4. So let's use f of 4 because we already know it. So f of 4, we're going to use, so that means that we're saying n is 4, right? So we're using this right here, n is 4, is going to equal f of n minus 1. Well, 4 minus 1 is 3, so that's f of 3. And remember, this means the previous answer. And then plus 12, my n right now is 4. So 12 times 4. I got that from here. And then what we're trying to do here is finish finding this mystery number, so we have our whole equation. So now I'm going to look here. F of 4 is 48. So I'm going to substitute 48. F of 3, the previous answer was 18. 12 times 4 is, wow, 48. So this is going to give us an equation that says that 48 equals, what is that, 16 here, 66 plus or minus, so it's going to have to be minus some other number. And it looks like it's going to be minus 18. Right, because if you did 66 minus 48, you got to borrow and carry 5, 16. 16 minus 8 is 8. 5 minus 4 is 1. So that has to be 18 there to make this true. So I put those together. I got 66. All right. So let's see now. So I'm going to change this to a minus. So that's my equation. I got it. F of n, I think, equals f of n minus 1 plus 12n minus 18. Now, I always test it. So we used f of 4 just to figure out everything. So let's do let's do f of 6. It's a big number. Let's find f of 6 using our equation. So let's pretend like we don't know f of 6. So f of n minus 1, that's f of 5, right? Because 6 minus 1 is 5, and that means the previous answer, plus 12 times 6 minus 18. We're pretending like we don't know f of 6. I mean, we do know it, but we're pretending like we don't. F of 5, I can look up and say that's 90. 12 times 6, by the way, this is a good one to memorize. It comes up a lot. That's 12, carry 1, 72. 72 minus 18. Let's see, 90 and 172, I can do that one. That's 162 minus 18. I'm going to come over here and subtract. I'm going to have to borrow, so that's what, 5, 12. 12 minus 8 is 4. 4, 144. Yes, that's true. Let me write all the rest of my f's of 6's here. Look, that's what I got. That's so cool. So I want to use our equation also to find like terms 2 and 1, because like they didn't give us terms 2 and 1. Find f of 2 equals f of f of 1 plus 12 times 2 minus 18. It's a recursive formula. We can't use it to go backwards. We don't know what f of 1 was. So we can't, we probably could work out how to use this formula to do this, but without knowing f of 1, we can't find f of 2, because a recursive formula depends on knowing the previous, right? This is just fancy math for the previous answer. Well, I don't know the answer that came before 2, so I can't find it because I don't know 1. There is another way to find this, though. You know how the second difference was 12? Check this out. So I know that to get a 12 here, this would have had to be 18, right? Because 18 plus 12 will give me 30. Well, then that means that 18 and this 18, that had to be the difference, right? Because to get 18 to 48, I added 30. So it means this has to be 0. Pretty cool, huh? And then I could do that stuff again, right? Look at this. I know here this has to be a difference of 12. So this has to be 6, right? Because 6 plus 12 gets me 18. So for this difference right here to be 6, then this would have had to be negative 6. So I can kind of see why they didn't give us terms 1 and 2. It would be really hard to draw a rectangle with an area of negative 6. If that last part, like you didn't quite get that, that's okay, as long as you got how to use the formula. And we're going to do another one. So for our next one, we are going to just go straight from a set of numbers. Okay, for our second example, I already have the table of values, so I'd like you to copy that down and get your first difference and your second difference, and then we'll come back together. Do you have it? Yes, I just got my second difference. So now you're ready to write the first part of the formula. Why don't you pause and see if you can get the first part of the formula by yourself? You're back. That means you wrote the first part of the formula. All right, let's do it. So now we got to figure out the missing number. So let's use, I like f of 3. Let's use f of 3. Oh, this is going to work really well. Look, f of 3 equals f of 2, right? Because 3 minus 1 is 2, and that's the previous answer, plus 8 times n. If I'm saying f of 3, then I'm saying for right now, n equals 3. So that's 8 times 3, plus or minus the mystery number. Check this out. F of 3 equals, we already know f of 2 is 0, plus 24, plus or minus some mystery number, right? F of 2 is 0. They told us that. Oh, and f of 3 is 17. So f of 3 is 17, 0 plus 24, 24, minus, and I picked f of 3 precisely because I knew the answer. So I'm taking information I already know, and I'm using it to find the missing piece. 24 minus 17 is going to be 7, right? 24 minus 7 is 17. So what I just found here was I found the mystery number. And my mystery number now becomes minus 7. So that is my equation. Let's test it. Let's see if it works for, let's see if it works for 1. Okay, so let's do f of 1. We're going to pretend like we don't know f of 1, and we're going to try out our formula. So that should equal f of 0 plus 8n, which is 8 times 1, minus 7, because we found that number. Okay, so f of 1, pretending like we don't know it, equals f of 0, which they tell us is negative 10, plus 8 minus 7. Negative 10 plus 8 is negative 2 minus 7. Same signs when you're adding or subtracting, the same signs mean they just pile up. Negative 2, negative 7 is negative 9. Math works. Yes.